Let's see the numericals on statically indeterminate structures. Okay, in last lecture we see numerical on statically determinate structures. If it is impossible to find out the internal forces by using simple or static equilibrium conditions, then that structures are called as statically indeterminate structures. A fixed beam is an example of statically indeterminate structures. Then how to find out the internal forces in statically indeterminate structures? How to find out the internal stresses in that statically indeterminate structure? Let's see by one numerical. Okay, for the composite section, fix at both the ends as shown in figure. Then find out the reactions at both ends and stresses in each part. Okay, first part is made by copper. Its area is 4000 mm square and its modulus of elasticity is 120 kilonewton per mm square. Second part is made by aluminium having area 6000 mm square and modulus of elasticity is 70 kilonewton per mm square. And third part is made by brass having area 5500 mm square and its modulus of elasticity is 100 kilonewton per mm square. So we have to find out the reactions at both ends and stresses in each part. The total elongation produced in that statically indeterminate structures is 0 because it is fixed at both the ends. So first of all, we assume the internal stresses produced in each member are pull type, tensile, and it is P1, P2 and P3 respectively. Okay, we assume that, consider this is first part, this is second part, this is third part. Okay, here I draw a BD of first part. Okay, this is first part and we assume that the internal forces produced in that part are tensile and it is P1. Okay, again we draw a BD of second part and a BD of third part. Okay, this is second part, this is third part, and we assume the internal forces produced in each bar are tensile and it is P1, P2 and P3 respectively. Okay. Then see at a joint of 1 and 2. Here is part 1, here is part 2. At a joint of part 1 and 2, there is a one force which goes towards the right side. Okay, and then we know the sign conventions. Forces goes towards right, we take positive, and forces goes towards left, we take negative. Simple. Then see at a joint of part 1 and part 2, there is a one equation, that is P1 goes towards right, it is positive, P2 goes towards left, it is negative, P1 minus P2 is equal to that force goes towards the right side, it is plus, it is 30 kilonewton. Okay, then we got a one equation for P1, that P1 is equal to P2 plus 30, and this is equation number 1. Again see at a joint of part 2 and part 3. Again at a joint of part 2 and part 3. Again we got an equation, that is P2 goes towards right side, P3 goes towards left side, P2 minus P3 is equal to C, of force at the joint of 2 and 3. It goes towards left, that's why it is minus, and it is minus 50 kilonewton. Okay, so this is second equation. Okay, see here we find out P3, that P3 is equal to P2 plus 50. P2 plus 50. This is our second equation. Okay, then we know principle of superposition. What is principle of superposition? Simply, according to principle of superposition, we know that total change in length is equal to change in length in each part, that delta L is equal to delta L1 plus delta L2 plus delta L3. But for statically indeterminate structures, that total elongation is 0. So we put 0 here, and we know that delta L1 is P1 L1 divided by A1 E1 plus delta L2 is P2 L2 divided by A2 E2, and that delta L3 is P3 L3 divided by A3 E3. Okay, then simply put all the values in that equation and find out the P1, P2 and P3. Simple. Let's see. What is P1? P1 is P2 plus 30. P1 is P2 plus 30. That is P1 is P2 plus 30 into what is L1? L1 is 500 divided by A2. Sorry, A1. A1 is 4000 mm square. A1 is 4000 mm square into E1. E1 is 120 into 10 raised to 3. That kilonewton per mm square convert into Newton per mm square. Okay. Then plus what is P2? P2 we don't know. We have to calculate that P2. P2 into L2. What is length? Length is 400 divided by what is area? Area is 6000. Okay, what is E2? E2 is 70 into 10 raised to 3. Then plus. What is P3? P3 is again P2 plus 50. It is P2 plus 50. Into L3. L3 is 600. Divided by area. Area A3 is again 5500 mm square. And E3 is 100 into 10 raised to 3 Newton per mm square. Okay. By doing a simple calculation, we take a common P2 and find out its value, and that P2 is minus 27.81 kilonewton. We take all values in kilonewton, that's why we got P2 is minus 27.81 kilonewton. Simple. We put that P2 in equation 1 and equation 2, and we got a value of P1 and P3. That is P1 is equal to 2.19 kilonewton. 2.19 kilonewton, and P3 is equal to 22.19 kilonewton. Simple. We got the reactions at the ends, and that reactions at the end, the left end reaction is P1 and right end reaction is P3, and we got that reactions at the ends, we got value of P1, P2 and P3. Second, we have to calculate stresses in each part, and we know how to find out that stresses. Simple, we know stress is nothing but the force upon area. Stress is nothing but the force upon area. Then we have to find out stress in first member, that sigma 1 is equal to P1 by A1. We know force in first member is 2.19 kilonewton. Convert into Newton, 2.19 into 10 raised to 3 divided by area of first member is 4000. Simple, do that calculation and find out the stress in first member, that sigma 1 is 0.727 Newton per mm square. Here is positive value, that's why that stress is tensile stress. Okay. Again, by doing that simple calculations, we find out the stress in second member, that is sigma 2 is equal to P2 by A2. Put all that value. P2 is minus 27.81 8.81 into 10 raised to 3 divided by A2. A2 is 6000. We have got the stress in second member and it is minus 4.515. Okay, minus sign indicates that this is a compressive stress. Okay, again find out stress in third member, that is sigma 3 is equal to P3 divided by A3 is equal to P3 is 22.19 into 10 raised to 3 divided by A3 is 5500. We got stress in third member and it is 4.165 Newton per mm square. The positive value says that it is tensile stress. Okay, so by using the principle of superposition and assuming the forces in that statically indeterminate members are pole type, and by using equations we find out the internal forces and stresses produced in that statically indeterminate structures. Okay.